Welcome to Unit 11 on vectors. Day 1 focuses on non-right triangle trig, specifically the area of a triangle and the tool we're going to develop called the law of sines. Area of a triangle from back in middle school is 1/2 base times height. The base being this bottom B and the height being this imaginary altitude. Can we, however, create a formula using just the angles ABC and or the sides, small ABC, without this altitude needed? To do that, we're going to focus our energy onto this right triangle over here. Can we create a formula using angle C, side H, and side A? The answer is we can. Sine of C equals opposite H over hypotenuse A. Solving for H gives us A sine of C. In the area formula, 1/2 B, replacing the H with what it equals, A sine of C, generates this formula, A equals 1/2 AB sine of C. Finding the area of a triangle with actual pieces of that triangle. How we're going to interpret? It's a corner. One side, the inclusive angle, and the other side. Area formula, A equals 1/2 side times sine of the inclusive angle. Obviously, we could have used any corner. If we used corner B, we would have said 1/2 of C times A times angle B, or 1/2 of C times B times angle A. Let's take that formula and use it. Given this triangle, we have what we need. Side, angle, side from geometry. 1/2 AB sine of C equals 1/2 6 times 4 times sine of 48. Plug that into our calculator. 8.92 square units. Let's take that tool and see if we can develop something even more powerful. Given a triangle, its area, well, that's one corner. We said we also could have said 1/2 BC sine of A, or 1/2 AC sine of B. Obviously, the same triangle, same area, all three of these formulas will generate the same value. Can we manipulate this equation somewhat? First thing I see, let's get rid of the halves. AB times sine of C always equals BC times sine of A, always equals AC times sine of B. Powerful, but we can do something even more to manipulate it. Let's divide all three pieces by the product of the three sides, A, B, and C. Some good sound algebra simplification. Let's get rid of the factors A and B here, B and C here, A and C here, leaving us with the sine of an angle divided by its side opposite always equals the sine of another angle divided by its side opposite equals the sine of the third angle divided by its side opposite, known as the law of sines. This formula applies to each and every triangle. Right triangle or not, very powerful tool we will use again and again on non-right triangles. So now that we have this, let's use it. What I'm going to put as a little reminder in here is we're going to always look for an angle side pair. That means an angle and the side across from it. If you have that, law of sines is perfect. What we would be finding in this setup is this opposite side of 32. Sine 110 divided by 18 equals sine 32 divided by x. Cross multiply, let's be a little quicker this time. X equals 18 sine 32 divided by sine of 110. And our calculator generates x to equal 10. Let's take another example. Looks like if we want to find the area of a triangle, we need a corner. We have a side and two angles, not two sides and an angle. How can we get another side? In particular, maybe that side right there. Well, it doesn't look like we have enough known pieces to apply the law of sines. However, we do. Basic thing, all three angles of every triangle always add up to 180. So we do indeed know this third angle to be 60 degrees. Hence giving us that side angle pair we want. Sine of 60 over 10 equals sine of 80 over x. Cross multiply. X equals 11.4, which makes sense. It's opposite the biggest angle, hence it's got to be the biggest side. Now I do have a corner, so I can find the area. 1/2 10 times 11.4 times sine of 40, and the area of that triangle is 36.6 square units. All right, let's do one more. 3 dimensions given. Let's draw the triangle. Angle B, 36 degrees. Angle C of 70. And side B across from angle B is 4. If we want to solve this triangle, what does that mean? The answer is find all missing sides and angles. If we wanted to after that, we could then find the area. The way this is setting up, that 36 and that 4, that angle 70, we're going to find side C first. Sine 36 over 4 equals sine 70 over C. C equals 6.4. Can we get angle 3? Yes, we can. Subtract from 180. Angle A is 74 degrees. And we have another law of sines. Sine of 36 over 4 equals sine of 74 over A. A equals 6.5. And again, if we looked at largest side, opposite largest angle, they work. 74 over 6.5, 70 to 6.4, 36 to 4. These two angles being very close to each other, would expect 6.5 and 6.4 to be close, and they are. If we want to take this problem one step further and find the area, not necessarily included in the solving the triangle, but we can apply this formula. We'll pick any corner we want. I'll choose 1/2. A to be 4, B to be 6.4, which means we have to use the sine of, that's right, 74-degree angle. This corner right here. Plug that into our calculator. We can pretty much move to degree mode and stay there for the remainder of this unit. There might be a few opportunities where we'll use radians, but mostly degrees. 1/2, 4 times 6 times sine of 74, 12.3 square units. So that ends our lesson on law of sines and area. Next, we're going to focus on this topic. What happens when given a triangle, side, 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 and no angles? According to geometry, side, 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 guaranteed triangle congruence. So we know these angles exist. We know we can find their measure. How do we do it? The answer will be a new law called the law of cosines.